Hello friends, today we are going to discuss about the formability of the material. I am discussing here the contents like the introduction regarding the formability and the forming limit diagram. The forming of the metals into the desired shape is almost the oldest fabricating technique. Metal forming is an economical method of manufacturing the components because loss of the material is too less. It is a process in which the desired shapes and the size of the components are obtained through the plastic deformation of metal. Sheet metals are widely used for industrial and consumer parts because of its capacity for being bent and formed into intricate shapes. Sheet metal parts comprise a large fraction of the automotive, agricultural, machinery and aircraft components as well as the consumer appliances. Successful sheet metal forming operation depends on the selection of the material with the adequate formability, appropriate tooling and design of part, the surface condition of the sheet material, proper lubricants and the process conditions such as the speed of forming operation, forces to be applied, etc. A number of sheet metal forming processes are available such as shearing, bending, deep drawing, stretch forming, stretch drawing, press forming, hydroforming. Each process is used for specific purposes and the requisite shape of the final product. Shearing. Irrespective of the size of the part to be produced, the first step involves cutting the sheet into the appropriate shape by the process called the shearing. Shearing is a generic term which includes stamping, blanking, punching, etc. When a long strip is cut into the narrower bits between the rotary blades, it is called slitting. Blanking is the process where a contoured part is cut between a punch and the die in the press. The same process is also used to remove the unwanted part of a sheet, but then the process is referred to be punching. Similarly, the nibbling, trimming are a few more examples of cutting the process using the same principle of shearing process. Bending. Bending is the operation of deforming a flat sheet around a straight axis where the neutral plane lies. It is a very common forming process for changing the sheets and the plates into channels. Straight line bend in sheet metal is I am showing here in the slide. Spring back is a major problem during the bending of the sheets that occurs due to the elastic recovery by the material causing a decrease in the bend angle once the pressure is removed. The spring back can be minimized by introducing the excess amount of the bending so that the finished bending angle is the same after the elastic recovery. However, a careful estimate of the elastic recovery based on the mechanical behavior of the sheet material is necessary to achieve the same. Deep drawing. Deep drawing is a sheet metal forming process in which the sheet metal blank is radially drawn into the forming die by the mechanical action of punch. It is thus a shape transformation process with the material retention. The process is considered the deep drawing when the depth of the drawn part exceeds its diameter. This can be achieved by redrawing the part through a series of dies. The various factors that affect the flow during the drawing are discussed here. First one, that is the ductility. It is the ability of the metal to undergo a change in the shape without fracturing. Yield strength is the point at which a permanent change of the shape occurs in metal. A low yield strength is desirable so that the metal flow begins easily without tearing near the punch radius. Second one is the blank holder pressure. The blank holder pressure should be only high enough to prevent wrinkling of the metal. Too high values of the blank holder pressure causes the higher frictional forces and may cause the metal to be restricted and result in tearing of the cup of the wall. Lubrication. In drawing, a lubricant is generally applied to reduce the friction. Shallow draws in the light stampings can be produced with little or no lubrication. But when forces becomes larger and wrinkling and tearing becomes a problem, lubricant should be necessary. Drawing speed. It is the velocity at which the punch penetrates the workpiece. When cranking or excessive thinning occurs, the drawing speed should be reduced. In general, the drawing speed should be less for harder and more for ductile materials. Die clearance. Die clearance, it is nothing but a gap between the punch and the die. It should be 7 to 20% of the metal thickness. A proper die clearance is been necessary for a good component to be manufactured. The deep drawing process is applied with the intention of manufacturing a product with the desired shape and no failures. The tools, the blank and the process parameters define the deep drawing of a final product shape. An incorrect design of the tools and the blank shape or an incorrect choice of the material and the process parameters can yield a product with a deviating shape or with the failures. Here in these slides I have shown a different common defects that are been present during a deep drawing process. Now we are going to learn about the forming limit diagram. Sheet metal forming is a compression tension forming process, involves a wide spectrum of operations and flow conditions. The result of the process depends upon a large number of the parameters and their interdependence. The selection of the various parameters is still based on the trial and error methods. It is necessary to assess the formability experimentally before manufacturing the actual component to judge its stretching capability. The stretching primarily depends upon the limit strengths. The limit strengths are sensitive to the strain distribution as shown by the Killer and Goodwin. The limit strengths are described by the concept of the forming limit curve. The forming limit curve represents the onset localized necking over all possible combinations of the strengths in the plane of the sheets. The forming limit diagram shows the metal formability with the less cost. It is typically represents the maximum permissible range of major and minor strengths that a typical sheet material can undertake without failure. Practical formability analysis is represented by the FLC or FLD. A forming limit diagram is a graphical representation of the stretching capability of the material. The stretching limits are a function of the major and minor strength. A forming limit diagram is shown here. This diagram is applicable for the first forming operation. Subsequent forming operations change the shape of the diagram as the material is subjected to the multiple strain paths. A combination of the major and minor strains will fall in one of the three zones: safe, marginal or failure. If a point representing a major and minor strain combination lies below the green band, it is in the safe zone and the breakage should not be expected. If a point lies between red and the green band, it is the marginal zone and the periodic breakage may occur. Points lying above the red band are the failure one and the breakage will be frequent problem. A dye or lubrication change is generally required to remedy such problems. Points that fall in the undefined region should be replotted with the major and minor strains switched. The shape of the forming limit diagram is approximately constant for all the stages. The curve moves up and down the major strain axis as a function of the steel sheet characteristic.